This this is chymotrypsin catalysis. This one is a peptide chain. This one is a chymotrypsin, and this one is the peptide bond. Now definition. We have electronegativity or electronegative molecules. They want electrons to themselves more, or they want more electrons. So, number one, there are two molecules, and the goal is to break down the peptide bonds and to create amino acids at the end that can be used or reused again to create another set of peptide chains. Now, so first, we have an electron chain transfer. So, electron transfer from here. So, it's just a storage. It looks like a storage of electrons. See, histidine and serine 195 are both the reactive sites. So, if you cleave serine 195, the chymotrypsin becomes reactive. Now, in this part is activate muna. Electrons transfer from one place to another, and the oxygen from serine 195 reacts in or attacks the partially positive carbon. Why is it partially positive? Because the oxygen is very electron negative. Electron negative, it wants electrons more to itself. So, the electrons here transfer there, creating a tetrahedral electron that is a tetrahedral na intermediate, which has a very reactive or unstable na form. Now, due to this, the excess electrons will have to move to here so that the oxygen can have a double bond, which is more stable kapag naka-double bond si oxygen mo. Now, ang electrons nag-move lang from here to here. N is more electron negative than your carbon. That means more electronegative siya. Partially negative, here partially positive. Now, malapit lang dito sa molecule na ito is our proton. Our proton is positive or partially positive. Why? Because of our electron negative N. This is more electron negative than H. So the electron from here goes here and here. This one cleaves or mag-break ang bond dahil wala na silang i-share na electrons kasi mag-transfer naman yung electrons from there to there and balik sa storage ng electrons sa chymotrypsin. This reaction will form our double bond here, our acyl serine 195 intermediate, and this one, our broken kuha na N terminal. This will go to our system to be reused as an amino acid. And we have our chymotrypsin, but it is still very reactive kasi ano pa siya, activated kasi wala pa yung si serine. Now, electrons kasi nakabalik na siya sa storage, balik na naman, magkakaroon na naman tayo ng jumping of electrons or path. Ano nga yun yung term? Basta yun, mag-jump ng electrons. Now, here from aspartate 102, electron jumping, H2O is H2O is all around the nucleus or all around the atom or molecule or basta dira sa palibot. So the water is a polar substance. We have partially negative oxygen and partially positive H's. Because of the electron transfer, the N now becomes electronegative. Ay, electronegative na nga dahil siya na partially negative na dahil siya. Hindi, partially negative na siya. And then may excess pag yung electron from the jumping of electrons here. So, grabe na siya ka rich in electrons. Now, may sa palibot merong hydrogen which is partially positive. So, yun yung ina-attack niya. And then, so mag-cleave ito. Cleave. After cleaving, may excess nga electrons sa imo oxygen which attacks the partially positive na carbon. This is due to due to the electronegativity of our oxygen. This creates now our second na tetrahedral, which has electrons here, and because very near lang sila ng electron dot, our oxygen from serine 195, this one, di ba, diri na ang electron, move siya diri. So the electrons is right here. But because of the electronegativity of oxygen, which is this one, it pulls to itself the electrons, and this becomes very reactive to a partially positive hydrogen near it. So it will attack the hydrogen, and the bond here will break because this will take away the positive side, and then this became partially positive due to the N, which is also an electronegative, but because gikuha na si hydrogen ng oxygen, so the N here will transfer there, the electron here will transfer there, and back to where it came from, to the storage. This is our final product, which will become another AA to be reused into the system. And finally, we have again the chymotrypsin. This one is the chymotrypsin.